Satu, tes. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. Jadi walaupun undangan awal kita jam 10, tetapi ada info terakhir, acaranya akan dimulai jam 10.30. Karena narasumber kita hari ini kebetulan di pagi hari ini ada meeting dengan pimpinan di sana.
Terletak di Provinsi Bengkulu yang dikenal sebagai The Land of Rafflesia serta memiliki sejarah yang sangat panjang. Pada tahun 1982, Universitas Bengkulu pun didirikan dan menjadi salah satu universitas terbesar di Asia Tenggara. Sebagai bagian dari Universitas Bengkulu, Fakultas Teknik Universitas Bengkulu berperan penting dalam memajukan bidang keteknikan melalui pendidikan, penelitian, pengabdian masyarakat, serta menciptakan lulusan unggul yang akan turut serta untuk membangun bangsa Indonesia. Fakultas Teknik Universitas Bengkulu secara formal baru dibentuk pada tahun 2006, tetapi program studi telah didirikan dan menerima mahasiswa sejak tahun 2003. Hingga saat ini, Fakultas Teknik telah menunjukkan kemajuan dan perkembangan yang luar biasa. Fakultas Teknik Universitas Bengkulu telah mencetak lulusan yang sudah bekerja dan tersebar di seluruh Indonesia. Fakultas Teknik Universitas Bengkulu terus berkomitmen untuk menumbuh kembangkan setiap mahasiswa untuk bisa berhasil di berbagai bidang sesuai dengan keahliannya. Fakultas Teknik Universitas Bengkulu memiliki visi, yaitu menjadi fakultas unggul, berkarakter, dan berdaya saing tinggi di tingkat Asia. Adapun misi dari Fakultas Teknik Universitas Bengkulu yaitu 1. Menyelenggarakan tata kelola yang profesional dan berorientasi kepada pelayanan. 2. Menyelenggarakan pendidikan atau edukasi yang berkualitas, kreatif, inovatif, dan berakhlak mulia. 3. Meningkatkan kualitas publikasi ilmiah baik nasional maupun internasional melalui riset yang unggul. 4. Menciptakan suasana akademik yang kondusif dan nyaman bagi semua sivitas akademika. 5. Menjadikan mutu sebagai orientasi utama dalam pengelolaan sumber daya. 6. Melaksanakan pengabdian masyarakat dan kerjasama nasional maupun internasional. 7. Memanfaatkan teknologi informasi dalam penyelenggaraan akademik yang lebih efektif dan efisien. Serta 8. Menghasilkan lulusan yang kreatif, inovatif, mandiri, dan kompetitif. Fakultas Teknik memiliki 6 program studi, yaitu program studi informatika, program studi teknik sipil, program studi teknik mesin, program studi teknik elektro, program studi arsitektur, program studi sistem informasi.
Fakultas Teknik Universitas Bengkulu akan mengokohkan dirinya sebagai fakultas yang memiliki reputasi di tingkat Asia. Internasionalisasi telah mulai dilakukan, kerjasama dengan universitas terkemuka di Asia, standarisasi manajemen, serta publikasi hasil penelitian tingkat internasional, dan pertukaran mahasiswa dengan universitas terkemuka di dunia. Hampir semua lulusan Fakultas Teknik telah bekerja di berbagai bidang, baik di BUMN, perusahaan swasta, ASN, maupun membuka lapangan pekerjaan sendiri berbekal soft skill yang mereka miliki selama perkuliahan. Mari bergabung dan raihlah sukses bersama kami.
Fakultas Teknik Universitas Bengkulu memiliki dosen yang merupakan lulusan universitas dari berbagai belahan dunia. Fakultas Teknik Universitas Bengkulu juga memiliki sarana dan prasarana penunjang akademik dan non-akademik, diantaranya laboratorium di masing-masing program studi yang sudah sangat menunjang pembelajaran, ruang perkuliahan yang nyaman dengan dukungan multimedia, ruang studio pembelajaran, ruang pelayanan, perpustakaan, fasilitas olahraga, serta gedung kegiatan mahasiswa Fakultas Teknik yang representatif. Agar mahasiswa Fakultas Teknik Universitas Bengkulu memiliki daya saing tinggi, beberapa program peningkatan soft skill telah dilakukan, di antaranya Fresh Graduated Academy atau FGA bekerja sama dengan Kominfo Republik Indonesia dan didukung oleh Global Technology Company seperti Microsoft, IBM, Cisco, AWS, Alibaba, dan lain-lain. Program Fast Track 3+2 bekerja sama dengan Minchi University Taiwan, di mana mahasiswa Teknik Universitas Bengkulu bisa melanjutkan studi master dengan dukungan beasiswa. Sertifikat kompetensi keahlian bagi mahasiswa bekerja sama dengan lembaga dan badan sertifikasi serta asosiasi profesi. Pelaksanaan Kampus Merdeka, Merdeka Belajar bekerja sama dengan PLN, PUPR, Balai Wilayah Sungai, Badan Kerjasama PTN Bidang Teknik, dan berbagai BUMN dan industri. memberikan bantuan berwirausaha bagi mahasiswa yang berminat membuka lapangan kerja sendiri, serta kesempatan mengembangkan diri melalui berbagai organisasi dan unit kegiatan mahasiswa. Sarana dan prasarana di Fakultas Teknik terus akan ditingkatkan seiring dengan komitmen yang tinggi dari Universitas Bengkulu untuk memberikan fasilitas dan dukungan sarana dan prasarana sebagai bagian dari bentuk layanan terbaik bagi masyarakat.
Oleh karena itu, saya sebagai Rektor Universitas Bengkulu menyampaikan bahwa Universitas akan memberikan dukungan yang penuh terhadap penyediaan sarana dan prasarana yang dibutuhkan oleh Fakultas Teknik Universitas Bengkulu. Hidup teknik!
Kurikulum pada semua program studi telah dirancang agar sesuai dengan perkembangan teknologi yang bergerak cepat. Dengan didukung dengan staf pengajar yang ramah dan bersahabat, membuat suasana belajar semakin menyenangkan. Tidak itu saja, layanan internet yang handal dan bisa diakses kapan dan di mana saja di dalam kampus, membuat belajar semakin mudah dan bisa cepat mendapatkan informasi. Hingga hari ini, Fakultas Teknik telah menciptakan banyak prestasi yang diantaranya 10 besar pada Indonesia Energy Marathon Challenge atau IEMC dari Prodi Teknik Mesin, pertukaran mahasiswa melalui program American Indonesian Exchange Foundation di Saginaw Valley State University, dan Tennessee Technology University Amerika Serikat dari program studi teknik elektro. Dosen Fakultas Teknik menjadi dosen tamu di Raja Mangala University of Technology Sriwijaya atau RMUSTV Thailand dari program studi teknik elektro dan teknik mesin. Dosen Fakultas Teknik menjadi peneliti terbanyak tingkat Universitas Bengkulu untuk publikasi di jurnal internasional bereputasi dari program studi teknik sipil, serta program kreativitas mahasiswa yang telah banyak berprestasi di tingkat nasional. Alumni Fakultas Teknik telah banyak diserap oleh lapangan kerja dengan bekal kompetensi dan soft skill yang mereka miliki, membuat masa tunggu kerja pun relatif singkat. Berikut beberapa tempat alumni Fakultas Teknik bekerja adalah BUMN dan BUMD seperti PT PLN, PT Pertamina, PT Telkom, Bank Nasional, dan Bank Daerah, dosen di beberapa PTN dan PTS, PNS daerah dan pusat, melanjutkan
Assalamualaikum, selamat datang Profesor Hazli.
Waalaikumsalam. Boleh dengar ke?
Boleh Pak, boleh.
Boleh. Okey, terima kasih.
Waalaikumsalam.
Pak Noval,
Ya, Pak Helmizar.
monggo silakan Pak Noval.
Okay, thank you. Good morning, Professor Hazli.
Morning.
How are you today?
Alhamdulillah, I'm good.
Alhamdulillah. So we were supposed to start at 10 o'clock, but I think you have something to do first. Yeah.
Yeah, I'm so sorry for that. Suddenly the Deputy Vice Chancellor want to meet me.
Okay. So we are happy today that we are going to have a public lecture. This is a program that is becoming routine in our university. So we have been having 2 public lectures previously by Japanese professors, and now we have you as our speakers today. We are trying as much as possible to provide an opportunity to our students to enlarge their knowledge and horizon, and so that they become better prepared for their future. There is some introductory remarks I supposed to be given by our dean. So, Pak Hemizar, please.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Yeah, it is a great honor for us having Professor Hazli today. to give our public lecture entitled Application of Nature-Inspired Optimization of Algorithm in Power System Research. I know that today Professor Hazli also will cover about renewable energy. So I hope everyone enjoy our public lecture today, and hopefully in the future Professor Hazli will give a public lecture not in online mode but in offline mode. Hopefully,
Inshallah.
hopefully in the future. I think that's all from me. Thank you again. Thank you, Professor Hazli. Welcome to Indonesia online in online mode. Thank you.
Okay, thank you very much, Mr. Dean. Without further ado, I think. Oh, I forget. Let me try to introduce our speaker today, Professor Hazli bin Muflis. Is faculty at the University of Malaya. So he has a lot of researches, publication in power system theory. Today he will speak about a topic that it might be initially interesting only to electrical engineering student, but I remind the students from other departments also join this because there are some result courses that is talking about optimization using evolutionary approach, and that is applicable to many problems, not only in electrical power system, but also in renewable energy and many other. Actually, his link, a personal official link, is already been shared in our chat. So all the participants who would like to learn more about him can visit that link. Okay, I think that is a simple introduction to Professor Hasdi. Now we are going to listen for his lecture. Please, Professor.
Okay, thank you, Pak Novalia. Novalio, yeah, Novalio. All right, let me share my screen. Can you see the slide?
Yes.
All right, okay. So Bismillahirrahmanirrahim. Assalamualaikum and very good morning to everyone. First of all, I would like to thank Dr. Helmi Rizal for inviting me to share a little bit knowledge and experience that I have from my previous work and also so far as a lecturer, academician, and also as a researcher. So it is a great honor for me to share this little knowledge to everyone, and I hope that later after the presentation, if anyone have any question, you can ask the question. And although the topic as mentioned by Pak Novalio regarding power system, but one of the main topic here is about the nature-inspired optimization algorithm, or we call it meta-heuristic techniques. So yes, I mean, the same idea can be implemented for other purposes, not necessarily power system research. However, since my research area power system, I'll give examples on power system. But as I said, it can be used for many purposes. And the advantage of having the knowledge on the nature-inspired optimization techniques that will help you to do more research and also to do publication, because by using different technique will provide different result. All right, so the topic is about the application of nature-inspired optimization algorithm in power system research. Just for introduction, I have been in University of Malaya since 2003 as a lecturer, but as a student from my matriculation, my first degree, my master. So I have been in that. And at the moment, okay, yes, okay. So at the moment, I'm holding an administrative administrative position as they call it under cluster innovation. It's like a dean, but the focus is for research at the university level. Yeah? So I'm assisting the Deputy Vice Chancellor in terms of research direction. Okay, so for those who are not aware, maybe first time heard about UM in Malaysia. So yours is Bengkulu is here, right? Small one. Let me use the pointer. Okay, so this is Malaysia, Sumatra is here. I think Bengkulu is nearby here lah. So UM is the oldest university, very old, first in Malaysia, and actually it was from Singapore. Okay, our Prime Minister Tun Dr. Mahathir was from UM, and actually we have 5 Prime Minister from our university became the Prime Minister. Okay, so Alhamdulillah, in terms of position in the world, UM has a good ranking position. So the main vision here is to be a global university impacting the world, and our mission is to push the boundary of knowledge. All right, so this is the content of my presentation today. So I will talk about the challenges in power system. What is the current challenges from 2 perspectives? Number 1, I will talk about due to the renewable energy penetration, meaning at the current time now, the renewable energy like solar, wind, they are connected to the power system to produce electricity. So these are challenges. And secondly, extreme weathers. So nowadays also very difficult to predict the weather due to the climate change. Suddenly flood happening, for example, in Malaysia. So anything can happen now. So this will discuss from these 2 perspectives how the power system will have difficulty due to these 2 problems. Renewable energy penetration, or we call it distributed generation, and also from the perspective of extreme weather. And from that, I will relate it, what is the research gap or research question that everyone can explore the research area due to the DG penetration or extreme weather. Then I will talk about, I will provide a brief introduction about nature-inspired optimization, or sometimes we call it meta-heuristic techniques. So I will give some briefing about it. And thirdly, I will discuss about, I will provide example of power system research that using this nature-inspired optimization, which has been done by my previous students. And then finally, I will conclude my presentation. All right, so just for introduction, for those who are not familiar with power system, so as generation, to produce electricity, start from the generation or power plant. For example, the power plant can be a hydro type based on water running, or it can be based on steam turbine, whereby we heated the water to become steam and then turn the turbine to produce electricity. And then the electricity will go to the transmission line. So depending how far the transmission line can be 100 kilometer, 500 kilometer. And then at the substation, it will be distributed to different customer, because different customer, maybe a household like this, they need a low voltage power. But certain customer like factory, they need a high voltage level. So it's not the same. So it will be distributed. Okay, so basically this is a conventional power system network, starting from generation, transmission, and distributed. However, nowadays, everybody aware that renewable energy is starting to be emerged, and it is connected to the system. It can be connected at the distribution side, low voltage, or it can be connected at the generation side. So it can, for example, like solar panel, it can be for own consumption at the rooftop of your houses. It can be connected to the grid, or it can be without connection to the grid. So all of this type of renewable energy nowadays becoming more and more, and I believe another 10 years, the number will be increasing. And I'm aware that recently, like Indonesia also, they already have a floating photovoltaic system, one of the largest floating photovoltaic system in Indonesia, which is a good move. Okay, it can be biogas, geothermal, so different type of renewable energy. So if we look at the world view in general, from the perspective of the world, if you look at the graph on the right side, this one, you can see that the red one showing that the trend of renewable energy share as the power generation increasing. The percentage, the red one, is keep increasing. Okay, and this is last data is 2019. So now it also keep increasing. Okay, because all the countries in the world, like Malaysia also, they have policy on renewable energy, and recently they have a policy where the government not allow for setup of new power plant based on coal power plant. So there will be no new power plant based on coal, and also the current one, when the contract end after 20 years, government will not allow them to continue the operation. So this is the direction or policy from the government, and I believe many countries in the world, including Indonesia, have their own renewable energy policy, whereby everyone want to increase the share of renewable energy in the generating electricity. This is from Malaysia perspective. Okay, so if you look here from 2012, 2019, there was a significant increase of renewable energy in Malaysia. Okay, so if you look here, in Malaysia we have a lot of hydro, the blue one. Okay, however, after some time we didn't develop new hydro. Okay, but we are focusing more on the yellow one. Yellow here is the large scale solar. We call it LSS, large scale solar, and the amount of large scale solar is increasing. And the target for Malaysia by 2035, the renewable energy should be 40% as the main source of generation, electricity generation. And by 2050, the target is 70%. Main electricity will be generated from renewable energy. And in Malaysia, we are focusing more on solar, large scale solar, and also small scale or rooftop solar. So this is the target. All right, this is some example of the renewable energy in Malaysia, where it's already in operation. This is biogas. We also have small hydro, 6 megawatt, small hydro. We have also floating solar, 108 kilowatt, but it's small. It's not as like in Indonesia, very big, the floating solar, the new one. Biomass, okay. And then we have a lot of solar on the ground. This one lot in Malaysia. Okay, so this is the little bit detail on the location of the large scale solar, LSS, large scale solar, and so the capacity. So we are very focusing a lot in this large scale solar, and in fact the quota is still available for the company to invest in this project of large scale solar. So we see that there are a lot of penetration, connection of renewable energy in power system network. Usually we refer renewable energy when it's connected to the system as a distributed generation, or DG, distributed generation. So from this challenge, there will be some difficulty or research gap that need to be addressed. Number one, what is the optimal capacity of DG in the system? So I mean, renewable energy, although it is good, but up to a certain extent, we still need the conventional system, the big power plant based on the gas or hydro. That one we cannot eliminate, we cannot remove, because they have a large machine that have without it is very weak. Yeah, so anything happen in the system can be disconnected. Yeah, can be disconnected. Okay. So number one, what is the optimal? So optimal referring to the optimization. So if we install DG without proper sizing, optimal sizing, it can harm the system in terms of stability. Yeah. Number two, where is the optimal placement? Okay, where is the optimal placement? Because like photovoltaic PV, they need a good sun irradiance so that it can produce maximum electricity. So the location must be optimal, the position of the PV, and also the location where it will be connected to the system must be optimal. Because if we wrongly place the DG in the system, it can cause voltage instability, frequency instability, or it will cause problem to the protection. Then number three, once the system has been connected to the power system, next question is, what is the optimal power output? Active and reactive power. So for example, like solar panel, usually we know that it will produce active power. However, at the same time, according to the new standard also, they require the system to have capability to inject reactive power. Yeah? Okay, so excuse me, let me take a drink first. Sekejap, ya. Okay, okay, number 4, once the system or DG has been connected to the system, the next question is whether we need to change the configuration of the network. Yeah? Because if we don't change the configuration, it may harm the system in terms of stability and also in terms of the protection. And last one, what is the optimal type of DG? So which type of DG? Is it photovoltaic? Is it wind? Is it biomass that's suitable to be connected? Because all of these have different economic value. All right. The next challenge, number 1, I have discussed about the challenge of higher penetration of renewable energy in the system. So the next challenge to the power system is extreme weathers. Extreme weathers. So nowadays, it's very difficult to have a good prediction of the weathers. Suddenly, the prediction is no raining, but suddenly there's a raining. So in Malaysia, we have a lot of thunderstorm, thunder, lightning. So this is one of the challenge in Malaysia whereby the lightning strike to the transmission system and it cause tripping to the system. So this is one of the challenge. And then floods. Okay, I think this one Indonesia or Malaysia have the same problems. This is a photo of flood that happened in 2014 in Kelantan. In Malaysia, we have different state. So the whole state of Kelantan was flooded in that year. So this is the worst flood in 100 years in Malaysia. So because when flood happening, many of the substation, substation here will be flooded, and it will the water will enter the substation. So it will need to be tripped off for the safety of the system itself. If not, the flashover will happen. Okay. And then wildfire, kebakaran. Kebakaran. So this also can create a harmful to the system, the power system. And all of this event, it is referred as low probability, high impact events. Meaning the probability to happen, for example, flood, the probability is low, but once it happened, the impact to the overall system is very huge. Okay. And this is different type of extreme weather. It can be under geophysical, meteorological, hydrological, and climatological. So this is different type of extreme weather that happening, and we cannot avoid this. We cannot avoid these problems nowadays. It happen daily. It happen very frequent. And this is example of extreme weather that happened in this year in August in Hawaii Islands. Hawaii Islands. So this is one of the island. So you can see this one very nice environment, very nice houses area. But after the event, extreme weather, wildfire, it become like this. So it burned down all the houses. Okay, the same on the right side. You can see this. So this is and no one expected this to happen, because never happened. But the probability to happen is low, but when it happened, the impact is very huge, tremendous impact, and also causing 100 people die due to this extreme weather. And it was reported that during this time the wind is blowing very fast, 80 miles per hour. So that's why the fire can destroy a lot of houses here. Okay, although it is near the sea, nothing can be done. Right? So this is the impact of extreme weather. And if you look at the data around the world, we see that the extreme weather is keep increasing. Okay, from 1980 to 2018. Okay, and different color here represent different event, geophysical event, meteorological, hydrological, climatological. We can see that the trend are increasing. It's keep increasing. Okay, this is another data here. Okay, another data to 2020, the distribution of the extreme weather. The color here represent different problems. The red one, geophysics, green, meteorological, blue, hydrological, like flood, climatological event. And the size of the event here represented by the size of the bubble here. I mean, the larger mean the impact is huge. So here, Malaysia, you can see a lot of blue dot here, meaning we are very prone to floods. And you can see the impact in China. We can see overall losses, for example, 1.8, 1.1 billion. So very huge losses. Look here, United States also have flood. It also have flood. Okay. And from the data, it is proven that many of the power outages, meaning the loss of electricity, were due to severe weather. Almost 39%. 39% is due to severe weather, extreme weather. Because nowadays the power system has been modernized, so it is very reliable and the infrastructure is very good. However, the external factors causing it to be unreliable, because it disrupt the operation of the system. Okay, this is example of extreme weather that impacting the power system performance or the electricity distribution at different states in the world. For example, in Argentina and Uruguay in 2019, there was a heavy rainfall that damaged the system, and the affected customer was 40 million. So you can see that extreme weather is really causing a lot of loss to the system, to the power system, electricity generation. Okay, China, Japan, USA. Okay, later I will explain a little bit about the event that happened in UK in 2019. Okay, and also in USA, Texas, 2021. So this data really showing that the impact to the customer that they not having electricity, the number of customer not having electricity is very huge, 10 million, 1.7, and so on. Okay. All right. So this is example of extreme weather that causing losing lot of electricity. So the chronology of the events: first, lightning strike at one of the transmission line here. You can see here, lightning strike near the overhead line. Okay, overhead line is the line of the tower, electricity tower between two substation. And then once the lightning strike on the line, transmission line, the large current due to the lightning will move. It will propagate. It will move to the substation. Okay, it will move to the substation. So the protection system, the circuit breaker will open to avoid this large current to enter the substation. Yeah, so protection open the line, so the large current will be stopped from entering the substation. Okay, so to avoid a major disruptive at the substation. And during this event, suddenly the wind farm on the north of UK here, they call it Hornsea, offshore wind farm, suddenly it is stripped off. It is not functioning. Okay, two unit not functioning. Okay, only one unit functioning. So when this happened, during this chronology, the steam turbine, this is the big power plant, okay, at the Eton Socon, okay, is also tripped off. Trip off mean it is not delivering electricity to the customer. So first, on the wind farm also stop, and then power plant, steam turbine also stop. So when this happened, many of the distributed generators, DG, distributed generators, mainly solar, they will see in the system that somehow there is changing in terms of the angle of the voltage. So they think that the grid is disconnected from the system. And when this happens, all the distributed generation will switch off. It will switch off. Okay, this is the standard. They will monitor the grid. If the grid has some changes, significant changes, they will trip off for the safety of the equipment. So now we'll see that there is an unbalance between the generation and the load. Load is the customer. I mean, the customer need a lot of power, but the system unable to deliver. So when this happen, the frequency will drop the frequency. So in Malaysia, the frequency of the system is 50 Hertz. So it will drop. So the same in UK, 50 Hertz, the normal. So we can see when for happen, frequency drop, frequency drop, and then you try to recover, and then suddenly one of the power plant here is stripped off, so frequency drop again. Okay, and then in order to restore it to the normal one, some of the load, the customer load, need to be removed from the system in order to recover the frequency. Another event, this one quite new, in 2021 in Texas, America. Texas is one of the state in America. So they never thought, they never think, or they never anticipate that this event can happen. Okay, this event can happen because always they survive during the snow time, but for this time around, the system really unable to deliver electricity. Okay, so here you can see that Monday morning, 15 February, grid instability driven by high load and shortfall of incremental thermal generation. Lead Arcot. Arcot is the company in Texas that manage the electricity. So as a result, because unbalance happened between the generation and load, and they need to remove 10.5 gigawatt of demand, okay? Because there was in unbalance between generation and the load. So theoretically, the generation and the load should be almost the same. If there are some differences, frequency will drop. And why this happened? Because during this event, during this extreme weather, snow, many of their renewable energy, especially the wind farm unable to work. It become freezing. So I mean, it will not deliver electricity or power to the customer. Okay. And at the same time, some of the power plant also fail to operate because of the freezing of the water. The power plant, they need water to create to make a steam and then turn the turbine. So many of the power plant also become freeze due to very cold temperature at this time. Okay, so if you look at the frequency response again, when there was a differences between total generation and total load, total demand, frequency will change. So here we see that this is normal. This is starting 1000 megawatt load shut order. I mean, they need to remove some of the load in order to recover back. So here you can see 1418 megawatt outage, mean generation outage here, meaning the power
Prof. Hasli, halo. Sepertinya Prof. Haslinya keluar ini. Kita tunggu aja dulu ya.
okay, sorry, suddenly I lost this one again. Can I share back the slide?
Yes, of course.
Host disable participant screen
now,
sharing. Maybe allow
now
first.
it is allowed. Yes.
Okay, right. Sorry, suddenly the system, I don't know what happened. Okay.
Actually, I was also disconnected for a while.
Oh, so,
Yeah.
right. So okay, this one, is it during this time disconnected?
Yeah, around this time.
Okay, all right. So actually, sorry, I repeat again. So actually, I explaining about two example that causing problem to the system when extreme weather happen. Number one, in UK, United Kingdom. Okay, this one that causing 1.1 million people are affected. And secondly, I talk about the event that happened in US in February 21. More than 5 million are affected. So this first example, is due to the lightning strike. It is initiated by lightning strike, and as a result, many of the customer being tripped off from the system. The system unable to deliver electricity due to the generation has been tripped off, disconnected from the system. Yeah, this is one example. And then second example that happened in Texas, 15 February in US. If you look at the chronology here, you can see that the red one, the red one, we can see the number of customer that need to be removed from the system in order to recover the frequency. So 1 megawatt, 1 megawatt, 3 megawatt, 2 megawatt, 3.5 megawatt. So you can see the amount is very huge at the time, because when this happened, many of the wind turbine, they are freezing, they are not working, cannot work due to very cold temperature, and worsen because of the many of the power plant unable to operate due to freezing of the water and supply and also the gas. So that's why this happened. Right. In Malaysia mainly we have problem with flood. So this is some of the data. You can see that when flood happen, many of the substation need to be switched off. So it will affect a lot of customer. For example, this one 62,000 customer. And other area. So when flood happens, substation flooded, and now become worse because we have we call it flash flood, whereby it happened very frequent in Kuala Lumpur. Suddenly flood happened within 3 hours, it reduced very fast. So we call it flash flood. Okay. So the research question, number one, how we can predict the extreme weather. Okay, how we can predict how to model extreme weather. Okay, so this one actually not necessary. This area is in electrical or power system. This one, actually the civil engineers also doing this area as well, because they are the one who model the flood movement, the velocity of the flood, the depth of the flood. This is under civil actually. Yeah. And then second, what is the optimal service restoration following a catastrophic events due to the extreme weather? So how we can restore the system? Now imagine that suddenly flood happens, so we trip off the substation, so customer will not receive electricity. So what is the step when the flood is reduced? So how we can restore back optimally? And then number three, what is the optimal intentional islanding network? Later we have example on this one so that you can understand what is the meaning of intentional islanded network. And then what is the optimal movable DG during or after catastrophic events? So this is again the word optimal. So let's say we know that we have 5 or 10 diesel power generator that we can deploy to the area that was flooded. So the question is that what is the optimal number of DG of the diesel power that we can send optimally, because we don't want to send too many. So we need to understand the load at that area so that our combination of diesel generator that we will send will be optimal. It's not too much or too low. Then what is the optimal load and its priority to be served following catastrophic event? So how we can restore the load? Okay, I mean, we want to give power back. So how we can do that optimally? Which one we will switch on first? So this is about optimization. And then finally, what is the optimal system restoration once catastrophic event ended? So once the flood, for example, already finished, so how we can restore? We on back the system, but we cannot switch on everything at the same time. There must be a sequence of switching. So the question here, what is the optimal switching sequence to energize back the system? All right. So due to that two key challenges nowadays, we need to have a tools. I call it tools. I mean, that can handle challenges or challenging optimization problems. So we are using, we call it nature-inspired optimization to help us as a tools to do the optimization calculation. But in order to use this as a tools, we need to understand the problems clearly and also how we can model it clearly before we use this optimization, because it's just a tools. It's just a tools like a calculator. So if you feed it with wrong data or unsuitable data, for sure the result will be meaningful, and unmeaningful. Maybe the result is not useful at all. So first we need to understand optimization technique as a tools. So you need to understand the problems, what is the objective function, okay, what is the constraint, before we use these optimization techniques. All right. So before that, just a quick explanation. What is optimization? So basically optimization, whether we want to find the maximum point or we want to find the minimum point. So that's optimization. Okay, because the idea, if we want to maximize the profit, mean we find the maximum. We want to minimize the losses, so we find the minimum, minimization. Yeah. So okay, so this is the meaning of optimization. In relation to that, in this example, we see only one point, one maximum, one minimum. But in real life problems, in actual problems, there are a lot of local minima or local maxima. For example, looking at this graph, you can see that this is minima, this is also minima, minimum, paling rendah, ada dua. Tetapi, however, this one is the most lower, so we call it global minima, minimum yang paling rendah sekali lah, global minimum. So this is local. Okay, so this is optimization. And why we want to use nature-inspired optimization? Because we know that mathematically some of the problem can be solved using Newton-Raphson, for example. It can find the solution. However, mathematical technique, usually the way how they find the minimum and maximum is based on one direction search. Okay, once they already, let's say if we estimate the solution 1.2 here, so mathematically it will try to find until it reach here, and then the technique will stop. It will stop. However, actually this is not global minimum. Global minimum is the lowest one. But mathematically, if using mathematics, it will stop at this need and it will not go continue searching. But using nature-inspired optimization techniques, it has the capability to search other possible solution as well. So it will search a lot. They will look at different area until they find the global one. So this is the beauty of nature-inspired optimization technique as compared to mathematical technique. However, if the problem is very clear, like for example, load flow analysis, using Newton-Raphson, no need to use nature-inspired, because if we really understand the solution is within certain range, just use mathematics fastest. All right, so this is optimization. When we talk about optimization, you must understand what is the objective function. What is the objective function? What you want to try? Is it you want to maximize or you want to minimize? What you want to minimize? Is it the cost you want to minimize in terms of dollar and cent, or you want to minimize, what is it? Is it the environment problems? This is an example. So you need to understand what is the objective function, whether you want to minimize or maximize. And then you need to understand what is the constraint. Okay, equality, this one equality, this inequality. Equity, inequality is this one, inequality. So although the X, the solution, we know the solution, but the solution, potential solution is governed by this constraint. Okay, for example, let's say if you want to minimize the size of bottle, for example, so there must be a constraint whereby the bottle size must be within certain range. You cannot go outside that range. So that one we call it constraint. Constraint. Okay, optimization technique in general, it can be divided into meta-heuristic technique, or I call it nature-inspired, because the techniques were developed based on inspiration from the nature. Inspiration from the nature. Mean the researchers, for example, there are firefly algorithm. Mean the researchers get the idea looking at the firefly, how the firefly looking for a food. So based on that, they model this behavior in the mathematically as an optimization technique. Example, the particle swarm optimization. So PSO. So this PSO is based on the food hunting by the birds or the fish. So like the bird, when they're looking for food, they're going together. So the mathematician, the one who developed the technique, they look at the nature problems, how nature solve their problems, and they model this behavior as a tools to solve optimization technique. So under meta-heuristic technique, it can be evolutionary process. This one is like involving genetic algorithm, harmonic search, cultural algorithm, animal colonization or food hunting process, the one that I have explained about. So, and then thirdly, natural phenomena. This is based on physics. Physics, for example, gravitational search algorithm, water cycle algorithm, simulated annealing. So this is some example. So actually there are many other techniques. I didn't put it here. Too many nowadays. And then we have heuristic technique. Heuristic technique is based on trial and error technique. Sometimes we call it brute force. Brute force mean we know the solution. We know the solution, where exactly the solution in general. So we're using a technique to force so that the direction going to the solution. So that's why they call it brute force or branch action method. And then we have machine learning technique. This one very popular nowadays, especially when we talk about deep learning. So everybody aware, deep learning. So this is type of machine learning technique. Okay, and then we have mathematical technique. Okay, mixed integer non-linear programming, mixed integer linear programming, mixed integer quadratic, and so on. So a lot of techniques. So what is the differences between all of this technique and why I choose nature inspired? So basically, mathematical technique is a very good tools to get a fast result. However, the challenge of mathematical technique is that you need to model mathematically the problems correctly. You need to model the problem correctly before you can use the technique. Machine learning technique. Okay, this is the new trend nowadays. Deep learning. So it is like a black box, but the challenge is that this technique using the solution. So if that is not sufficient, it cannot provide significant result. Help me, Rizal. You can still hear me? Is it okay? Just to check.
Yes, we
Okay,
can.
right. Okay, all right. I'm afraid if suddenly I'm disconnected. All right. So heuristic technique. In order to use heuristic technique, you need to understand the behavior of the problems very carefully. So that comes to meta-heuristic technique or nature-inspired, like Firefly, genetic algorithm, and many more. So the advantage is that as long as you know what is the objective function and also the constraint, you will be able to use the technique. So that's the tuning. As long as you know what is the objective function, is it minimum, maximum, what is the constraint, you can use any of this technique. So this is the advantage of the meta-heuristic technique. However, the disadvantage of this technique is that it can be very slow. It can be very slow to solve certain problem. For example, 1 hour, sometimes 1 day or 2 days, because it work involving a lot of random process inside it. So The only challenge is it is taking some of the problem will take time to solve using this technique. Yeah? However, if you need to try different techniques so that you'll be able to find a good solution using different technique. By trying different techniques, you will identify which one is suitable. Because certain technique, like for example, particle storm optimization, it may be suitable to solve this problem, but for other problem, it is very slow. So we cannot guarantee that all of this can solve. It can solve, but it will consume time. So that's the challenge of meta-analysis technique. Therefore, for nature-inspired optimization technique, in my opinion, it is mostly suitable for planning purposes, design, planning purposes. But for real-time application, it is not that good because the solution to get the solution takes a lot of time, consume times. Whereas like AI, artificial intelligence technique, okay, it is fast because we model the solution. So whenever changes happen, it able to come up with the solution. All right, so this is about the optimization technique. Okay, this explanation details I have just explained earlier. So basically, the one that my focus is power system, but it can be used for many purposes. For example, in supply chain business, construction, biomedical, aerospace, or stock market. It can be used. Whatever problems that need optimal solution, whether to minimum or maximize, it can be used. The tools, meta-analysis technique can be used to solve that problems. Okay, so this is in general the flowchart of a type of optimization technique based on evolutionary algorithm. All the techniques actually have the same flowchart. It will start with the random population, or we call it initialization. So firstly, we will randomly generate potential solution. Okay, potential solution. And then from that, we check the constraint. Is it the parameters that we generate randomly fulfill the constraint? If not, we need to generate more. And then we need to evaluate the fitness. When I say fitness here, actually this one is referring to the objective function. So all the type of this flowchart is applicable for genetic algorithm, BBO technique, ES technique, DE technique. So a lot of technique there. And then this is comparison between genetic algorithm and differential evolution algorithm. So you can see the difference a bit significant, because but the flow will be the same. The flow will be the same. You will look at the initialization and check the criteria of termination to stop the analysis. Okay, and then this is the specific one for GA, where it has a parent selection, crossover, mutation, evolution, okay, and continue. And this is differential evolution algorithm. So different. So this is a flowchart based on swarm algorithm. Okay, swarm algorithm, same. You can see here, random population initialization is the same. Parameter constraint, okay, checking, is it fulfill the parameter constraint? If not, you need to generate again. And then we calculate the fitness or objective function. Okay, and then we try to improve the accuracy and again, continue. Okay, so on the right side here is the PSO and ACO, end colony algorithm. End colony, this is get inspired from the ant, movement of ant looking for food. Ant will look for food together. So the researchers model the ant to be as an optimization tool. This is natural phenomena based on physics. Okay, this is like gravitational search algorithm, and SA is simulatic annealing. Simulatic annealing. This is based on the propagation of the heat. Simulatic annealing. Okay. So in power system, there are a lot of problems. So number one, generation, then transmission and distribution. So optimization involved in all of this area, all of this area. when we want to set up a new substation, a new line, it will involve optimization. At least it will try to minimize the cost of purchasing new equipment or new transmission line. So that's optimization. So here you can see that, for example, for transmission load flow analysis, okay, I'm sure you know about load flow. So load flow usually we solve it using Newton-Raphson, but we can use meta-heuristic technique to solve load flow analysis, economic dispatch, and so on. This is distribution. Okay. So in this presentation, I will give example of how we can solve network reconfiguration using optimization technique. Load shedding meaning the customer, we select the customer to be removed from the system to stabilize the frequency. And then we'll talk about EV, electric vehicle coordination. Okay, don't worry, I'll give a little bit details later. And then I will talk about energy management. So all of this problem involve optimization technique. And my focus is more on planning. Okay, not for real time. Real time also available, but not much, because it's more suitable for planning. Because if you want to use for operation, you need to have a very fast techniques, fast optimization technique. All right. So where to learn about optimization? You can go to this link. We call it ERPs. ERPs. In this link, they provide a lot of examples, video about meta-heuristic technique, so that you can learn. In fact, they also provide the codes, the codes that you can take it and use it for your own research. And also you can get ideas or information from MATLAB for artificial intelligence. Okay, in this website, you will find a lot of resources that can help you to understand what is meta-heuristic techniques. Okay, so now let's see this example. Okay, example. Network reconfiguration. Okay, this is microgrid, EV, load shedding, restoration, power splitting, and also I will provide last part is on the potential of research related to power system resilience improvement. Okay, for network reconfiguration, okay, so basically usually if you look here, P loss, we want to minimize the loss. So this is the current flowing times with the length and also the resistance. So you'll get the power losses. So the idea here, if the source is very far to deliver to customers, so it will create a lot of losses. So this is the objective, and this is the constraint. What is the constraint? But during the network configuration, we must make sure that the voltage at all buses are within the allowable limit. And also B, the constraint, we need to make sure that the network configuration will not cause any flow back to the system. The system should be radial in nature. Okay, it cannot be ring type, it must be radial. So this is the objective constraint. So if you look at the network configuration from the perspective of planning, we want to minimize the losses. We want to minimize power losses, but at the same time, we want to improve the voltage magnitude. Okay, if you look here, this example, 16 bus system, 16 bus. The node here represent buses. And at the node here, there's a load, meaning connected to the customer. So if you look here, the system having 3 open point here. It's 1, 15, 16, and 17. So we can change the position of this open switch. Why you want to change? Because you want to minimize the power losses. Because different combination of open point here will provide different combination of losses. So this is the initial. So after we use optimization, we get a new solution here. Mean here initially closed, now we open. Here open, open here. Okay. So when we open this line, okay, it is radial. You can see from the source is go here. Okay, stop here. So it should be radial. So different combination, as I said earlier, different combination of open point here will provide different power losses for all the system. Okay, there. And I take a drink. And another perspective of operation, previously about planning, we plan mean initial, and then we change the configuration to be like this. So this is planning. We can use optimization to solve this to determine the best combination of open point. Secondly, operation. So we know that this is the initial position, and then the end position is like this. The open point we change, but the question is, what is the best switching sequence? Which one we want to close first, which one we want to open first, and what's the step? Okay, so for example, in this case, okay, initially look at the 16 here, 16, we close 16, and then we open, okay, or close this, open this, close, open this. Okay, so at the end, you will reach to this solution. Different switching sequence also can provide different problems. If the switching sequence is not correctly done, it can cause voltage increment or decrement at certain buses. The blue one, the circle here represent the buses or the load. So this is example of the work that has been done by my student. So in this work, they are using 118 test system, IEEE 118 test system, a large scale test system. And this one is his research objective. So in this work, he used evolutionary programming, particle swarm optimization, gravitational search algorithm, firefly algorithm. They use different technique, and then he compare which one is the best one. So if you look here, for network reconfiguration, for switching, if for 16 bus system, there are three open point, 1, 2, 3. So the possibility is 72 probability, mean we can try all the possibility combination. If the system increasing to 4 switch that can be opened, the probability will be 1,152. If 5, 2,088. So you can see the number of possibility is increasing when the number of switching is more. So it is not possible for us to try all the possibility. I mean, we try one by one. It's not possible because there are more than 2,000 probability or possibility of solution. So in that case, we need to use optimization. It will help us to address these problems. So this is example of the solution. So when we do network reconfiguration, this is the original. Using certain technique, it will boost up the voltage. The red, yellow, and blue. This one is low. This is for 33 bus system. This is for 69 bus system. This is for 118 bus system. So we change by doing this network reconfiguration. We can boost up the voltage. Okay, so this is the example of the solution for 33 bus system. So just to give examples, the step. This is using evolutionary programming, using particle swarm optimization. So the result will come up with the solution to show us what is the step. Okay, open 32, okay, close, open, and so on. So different switching sequence, you will see on the right side here, you will provide different power losses. For PSO 787, 803. So it provides different power losses. As compared to random switching, you can see random switching, the power losses is become very high, 153. This is 1,000 as compared to 700. Okay. Other example is a work on energy management system. Energy management system. So in this system, we assume there are photovoltaic, PV, there are battery energy storage here, and there are loads here. And the system are grid connected. So the problem here is how we can determine what is the best power output from each of the element, from the power plant, a solar power plant, from the battery energy storage, so that it will fulfill the load demand here, the houses here, the load demand. So you can have a look here, the research objective. Okay. Okay, objective number two, to develop a rhyme rate control strategy to mitigate solar PV output fluctuation in the developed microgrid system. Okay, this one. So, okay, this is about renewable energy. So, for a large scale solar, LSS, large scale solar, the large scale solar will have a battery, but the battery is not to store the solar, because for large scale solar, it is connected at the high voltage level. It goes to the grid. The power will go to the grid. It will move to the grid. Yeah. It will move. However, the battery that usually having together with the solar PV plant is to smooth the power output, because you know that the irradiance, the sun keep changing. It keeps changing. The sun areas keep changing. So the power output is not smooth. If you look here, the red one here, this is the power output. You can see it is increase, decrease. Yeah? So we need to have the battery to discharge power so that it will reduce the ripples. So in this example, left side here, you are using the MA, moving average technique to operate the battery. So the battery here, this one, it will operate, charge, discharge. So actually this battery will supply power to the PV so that the power output become smooth. Cannot be like this red one. It must be smooth. However, in this work, if you look at this paper, the student did extra work where here they proposed a new technique. Okay. PV smooth using proposed strategy. So he using new technique whereby he tried to reduce the operation of the battery. Why? Because we want to expand the lifespan of the battery. So you can see here, this one is the battery operation, charge, discharge, a lot of work continuously. But here you can see small work because the battery is used optimally. So this one using CIS method, okay, to smooth out the battery. Yeah. So you can see the red one is the actual power, and the green one is the smooth power. So we want to smooth the power output of the PV. So that's why we inject power from the battery so that the PV able to give a clean power. So in this one also, we are looking at the battery energy storage sizing, okay, because we don't want to have a battery that's very huge unnecessarily. So we need to buy something that really we need optimally. Okay, so that's why here we are looking also on the battery and energy storage system sizing. We want to know what is the optimal sizing that's suitable to cover that system. Okay, because in the system we need to look at the how many loads having there, how many fuel cells, solar. So a lot of things need to be studied. Okay, so this is the flowchart of battery energy storage system. I will not go details here, but just to show here, this is the objective function. Okay, objective function. Okay, and then this is the validation of the proposed battery energy storage sizing. Okay, so you want to know, is it the size that we have optimized is really the good one? Okay, so we compare with the trade-off method, trade-off method. Okay, trade-off method. And we found that the solution is much more optimal as compared to the other techniques. Okay, this one. So optimal battery energy storage system, kilowatt hour. Okay, this is different technique. So this is the cost. Okay, this is the cost. Best solution. This is different optimization technique, gray wolf technique, particle swarm optimization, bee colony, genetic algorithm, gravitational search algorithm. So you can see different technique produce different results. This is normal, It's normal. In fact, if you are using the same technique, for example, you're using gray wolf optimization and you run many times, each time you run, you will get different result. Okay, you will get different results. So because that's why here you can say for 10 trial runs, I mean, we run it 10 times. Okay, every time you run, we will get different results. Slightly different, it's not too much different, slightly. All right. So this is important characteristic when we talk about optimization. Okay, anyone who talk about optimization, they must provide this convergent curve. They must provide this convergent curve. So this is the function mean when we start with initial population is very high, and then we improve, the optimization will calculate again, try to improve, and you can see it drop. And it will stop from go down again. So this is the solution. It's saturated already. There's no more possible solution, saturated. So here you can see we increase the size of this one. You can see that it is reducing because this one is optimized. If maximize, it will increase. Depend on the objective function here. Okay, this is very detailed. Okay, I will skip this. Okay. Okay, so this is the trade-off method. This is proposed method. So we see that by using the proposed sizing method using optimization, we'll get better result. So 2,100, this one 2,056. So lower. So as a result, the cost also become lower. All right. So this is about the comparison. Next example, I will talk about the EV, electric vehicle. So this work has been conducted by my master student. The objective here is to manage the charging and discharging of the EV car, electric vehicle. So you can imagine, let's say you are staying in a housing area, and assume that everybody have EV. So afternoon, everybody come back from university, from the factory. They come back and then they want to charge their EV. So imagine that if everybody, let's say, and the area have 100 people, everybody start to charge their car, this 100 car. So it will cause a disturbance to the system because the system will become overload. The transformer, the cable, it become overload because when it was designed, it is not considering the EV in the future. So therefore, what is the solution? The solution is that we need to coordinate. We need to decide. Let's say we have 5 cars. So which car will be charged first and for how long? The same for the other cars. So this one can be done using optimization technique. So the optimization technique will determine in a day which car will be charged first and so on. Okay, so in this word, this is the objective function. Okay, just to show you. So we want to minimize because this is multi-objective. We want to minimize loss. We want to minimize the daily total cost, and we want to minimize the voltage deviation, the changes of the voltage due to the interconnection of the EV. So we want to do that. Here, this is minimum. We want to minimize losses, P losses, technical costs, this one, daily total cost, and this is voltage deviation. Okay. And this is the objective minimum, minimize, and this is the constraint. Okay, what is the constraint? We want to make sure when the EV start to charge, our decision to charge which one, it will not cause voltage drop. So the voltage at that certain point must be within the minimum and maximum. The same for the this one, state of charge of the battery. The system need to look at the capacity, the battery, the state of charge of the EV battery. Okay, and then in this work, we little bit advanced. We looking at the capacitor switching in a day. So in a day, how many capacitor need to be switched in order to support the charging? And also we looking at the on-load tap changes, OLTC switching in a day. So we want to, there is a maximum number allowables, so this become constraint, and also the how many time OLTC will be changes, so also a constraint. So we cannot do more than that, because if we do that, they will disturb the system, so there must be a constraint. Same like the state of charge. For example, we have minimum, maximum. So once the charging is happening, once the state of charge reach the maximum, it should stop the charging. Okay, so this is the test system. Okay, because we don't have actual test system, we are using a standard test system, or from literature test system. This one IEEE modified 31 bus, 31 bus. Okay, and then the blue one here, we assume the EV can be charged at any of these places, low voltage, at any places. And here you can see C1, C3, C4, this is the capacitor bank. So this one is practical. Okay, every substation have a capacitor bank. It can be changed, so that the capacitor bank is to inject reactive power. Okay, this is the size of the capacitor. You can change on and off of the capacitor. Okay, result. Without coordination or uncoordinated, if we allow everybody to charge their car at the same time, what will happen? So you can see there's surge of power here, the red one here. Okay, the power will increase drastically. And this is for different number of percentage of car. So the red one here is if 63%, and then 47 and 32%. So it's different. So you can see that, but in general, we see that once we allow everybody to charge the car, there will be sudden increase in terms of power. So as a result, imagine this is the transformer, everybody start to charge the car, so transformer become overloaded. The line also become overloaded. So it create issue in terms of security of the system. And also without coordination, you can see that this one, the voltage here drop 0.65 per unit. Okay, without coordination. And then now, if we coordinate, we decide which one to be optimally, which one will be charged first, which one is next round. So we can see that there is no increment of power. Okay, it's flat here, it's flat. Okay, and then the voltage also not dropping much, 0.9, the lowest. And then it's the power losses. Okay, this is coordinated. And then coordinated plus capacitor and OLTC. We are considering capacitor. We're considering capacitor and also OLTC to take effect as well. So we can see we'll get better result. But still, the power is kept. So there will be no overload here. Okay, there is no overload. Voltage also quite good. Lowest 0.92 something. And this one, coordinated charging, this one charging only. Okay, at the same time, if you know or you heard about V2G, vehicle to grid, V2G. Usually G to V, grid to vehicle, but at the same time nowadays, the EV car can be a source of power to the grid as well, if it is not being used. So here we are coordinating the charging and discharging with capacitor and OLTC. So you will get better result. Okay, that's end for the EV car, EV coordination. So now about load shedding, load shedding. Okay, I just give ideas how it is related to optimization. So if you look here, if the load and the generation balance, it become at the middle. Okay, the arrow here will be at the middle, 50 Hz, if it is balanced. But most of the time, if the generation here is loose or disconnected from the system, so it will reduce the voltage, the frequency. Okay, it will change the frequency. So load shedding basically can be categorized into conventional, adaptive, and intelligent. Okay. So let's see what is load shedding. Okay, look at this system. Okay, so the system is connected to the grid. And now what happened? When it's connected, it's okay. Yes, but when it's disconnected, frequency will drop. Okay, in order to recover the frequency, why frequency drop? Because when this disconnected, this system, the red one here, okay, will try to survive. However, because the DG size here, let's say 10 megawatt, but the load here is higher than 10. So the system will, the frequency will drop. So the only way, we need to remove some of the load so that the frequency will recover to normal back. Okay, so the question here, which loads, which combination, is it this load plus this load to be removed, or this one plus this one? So this is involved optimization technique. Okay. So this is an example of the work that has been conducted by my student. This is, you want to create the islanding. I mean, if this is the whole system suddenly disconnected, so this area should be able to survive because it has its own DG here. Okay, so it should be work. Okay, so that's the idea. We want to find out which load need to be removed, the combination. Okay, so this is some results. Okay, load demand before shading, load parity, load demand after shading. Okay, load demand. So the idea, we want to, when islanding happen, generation and total load is not balanced, so we need to remove some of the load. We need to remove so that it become balanced. So this is showing the result. Okay, I will not go detail there. Okay, so I just want to highlight this one. This is the conversion curve. So using Firefly plus PSO, we able to get the lowest result. I mean the better one, the most optimal one, as compared to the other color here. This is different technique lah. Firefly algorithm, PSO, GSA, and EP. So here comparison, for example, PSO, particle swarm optimization, Firefly algorithm, particle swarm optimization plus PSO, GSA, and EP. So as comparison, you can see that the minimum the fitness is the lowest, 0.59424. You can see the result, the value almost the same, but it's the lowest. Okay, so the load curtailment also the less, because the idea here, we want to shed the load as minimum as possible, because we want to maximize the electricity to the customer. So example of solution. So when islanding happen, the red one, you can see the voltage drop. So once the the load is shed, you can see it is recover the voltage. Okay, here lowest is 0.8 something here. But now by using load shedding, remove optimal load, it increased to here, which is good. The same goes for the voltage. You can see the voltage change towards a better result. Okay, and then this is more details about the IEEE 33 bus system, and you can see here for the case 1, we run it for 100 times. Why? Because every time you run, this is the sit back, or the challenge, the what you call it, the challenge of using meta-heuristic technique. Every time we run, we will get slightly different result, because later if you look at the detail of this technique, most of them have a random selection in their algorithm. So because of that, so the random selection will produce different results, so they will be a little bit different. So that's why we run it 100 times to confirm that what is the best, the global solution, the global, not the local, but the global solution. That's why we need to run many times so that we really confident. Okay. So here you can see Firefly algorithm plus PSO produce the most better result as compared to the others. Okay, next example. So I give a lot of example today. Okay. Next example is power system restoration. Okay, imagine that in your village, not village, not too small. Imagine in the country like Malaysia, suddenly blackout, power trip, the whole country blackout. Okay, So the question, which generator power plant need to be connected first? Which one? Which one we need to start off? We need to start to connect the electricity because we cannot on the whole country at the same time. It's not like switching a switch at our home, small, but this is a big power plant. Okay, once it stops, you need to take some hours to make it stable before it can be connected to the grid. So this is one area called power system restoration, where it can be restored parallel, different different power plant can be connected, can be on at the same time parallelly, or it can be bulk restoration. Example, let's say in the system you have island 1, 2, 3, and 4. When I say island here, this is the power system network that connected to each other. Okay, this connection. So this is parallel restoration. I mean, here we have bulk parallel. So this is parallel. I mean, we restore all of these small island together, and then after that we do connection. Okay. So okay, right, this one. Okay, so this is an example of the work that has been done. Power system restoration planning strategy based on optimal energizing time of sectionalizing islands. Okay, so this is the detail of the line to be removed, the active power. So we want to, if you look at the objective function here, is time, is related to time. So we want to have as much as we want to maximize as much as possible the connection, but at the same time we want to minimize the time because we want to make sure that the time of energizing the system is as fast as possible. Okay, so this is the detail, the energizing time each island. Example of the system, this is 39 bus system. So first we want to identify the island. We create the island, and then you have island 1, 2, and 3. So we will restore the island at the same time, parallel. I mean, we on step by step. After that, we connect here. The red one here is connection. After every island 1, 2, 3 has been energized, already operate, and then we connect each of this island. And we see that each of the island restoration have different time. For example, this one 195 minutes, this one 195 minutes, this one 180 minutes. It's not the same depending on the size of the system. And also which generator, for example, if you look island 2 here, which one? Is it this one or this one or this one need to be on first? So this is another problem. Then this is the what do you call it, the result in terms of the voltage, because we want to make sure that when we restore the island here, okay, the voltage at all buses should be within certain limit. Okay, example 2, this is more large, 118, 118 bus system, very huge bus system. Okay, so you can see that we on island 1, 2, 3, and 4, and then we connected it together. After we on parallel, we connect it. Okay, example, this is Malaysia. This is another area, power system splitting. Let's say this is Malaysia. So we will split the network into 4 categories, 1, 2, 3, 4. Okay, that's the practice. Why? Because whatever happened in one area, it can be moving to the other area, so it can cause problem to the other. So that's why we identify 4 areas. But the question is, what is the size of that area, the power system network? What is this? So this is involved optimization technique. Okay, so this is different technique, optimal network splitting algorithm. So we want to determine the size of the network. We split it. Okay, but in the operation, it's connected. But when anything happen, one island in one area, it will be disconnected because you don't want it to be escalated to the other area. So this is different technique. This example of the work we are using bee colony, artificial bee colony, or we call it ABC, artificial bee colony algorithm, to find the best point to be isolated or to islanded the area. Okay, this is the objective function. So what is the objective here? We want to minimize the power disruption, because as here we see, because the problem here, which line that we need to remove. So the idea here, we want to minimize the disruption, because some of the line here maybe it carrying a large portion of power. So the idea here, we want to minimize the disturbance. So that's why here minimum power disruption. Okay, so this is an example. So actually in this problem, we want to find the line that need to be cut off. Okay, that need to be cut off. But the combination should be the less power, the less power that causing problem. Another example, 118 bus. Okay, so we identify the red one is the line that should be disconnected. So we create 3 island, island 1, island 2, and island 3. So in operation, this is connected. Okay, however, when anything happen in island 1, for example, fault or generator trip, all of the red one here, the connection here will be switched off, so that the problem will not go to island 2. Okay? So that's the idea of network splitting. Okay, this is example of the work, the result. All right, this is my last slide on the because I talked a lot on about the renewable energy. When renewable energy connected to the system, you need to find optimal location, optimal sizing, change the water configuration, and so on. So this is just to give ideas of power system resilience. Let's say you have a system like this, suddenly raining and the water move very fast, and it causing the substation 72, 53, 51 to be flooded. So when this happen, we need to remove all of this. We need to disconnect. So as a result, you will see that some portion of the system will be here, will be supplied by the grid. Some portion, okay, microgrid 1, microgrid 2, it will be supplied by the DG here, distributed generation or renewable energy here. However, the size of this microgrid will depend on the capacity of the DG. If the DG, let's say 5 megawatt, so it cannot serve if the load here or the load here more than 5 megawatt. So you need to reduce some of the load. So we call it load shedding. Load shedding. We don't serve all the load, because without that it cannot work. Because the idea is that the generation must be equal to the load here. So if this is here, let's say flood happening here, so the size will be changed. Okay, the same if happen here. So different. This is the area of, we call it power system resilience. Okay, it involves a lot of stochastic modeling. Using Monte Carlo, for example. So from this illustration, the question that come out from that is, what is the optimal number of microgrid? Okay, optimal number of microgrid. So if you look here, there are 2 DG. So of course, this one not difficult. There will be 2 microgrid, 1 and 2. Okay, 1 and 2. But if many, how many? Depending. And what is the size of each microgrid? So each microgrid will cover which area? Which area it will cover? And then if we have a emergency mobile distributed generation like diesel generator, we can send the generator to supply certain power. But the question here, what is the optimal number of emergency generator? Then what is the suitable resilient matrix that's suitable to be used? So this resilient matrix actually referring to index to measure the resiliency of the system. How good is the system to respond to flood, for example? And then how to do proper planning of DG location and capacity to ensure high resiliency system. So what is the optimal location to put the DG? so that before flood happen, we already know, anticipate, so that you're able to supply certain load when that happen. And then how to model the flood movement and impact and its impact to the system. So flood movement, actually, civil engineering have done it. They have a lot of research in the area, and also we know that when the flood is gathered, and then it will move to certain direction. So this is related to model. Okay, so later we share this presentation. Is some of other work that has been done. All right, so to conclude my sharing today, number one, nature-inspired algorithm, or we call it meta-heuristic technique, it can be a good alternative. I say alternative because not necessary to be used. If the mathematics able to solve the problem, use mathematics. No need to use nature-inspired optimization technique. Okay, so nature-inspired optimization technique is suitable for planning purposes or problems that mathematics cannot handle. So this can be an alternative. Secondly, we have seen that from the statistic that happening around us as well, the renewable energy and extreme weather are frequently is happening now. More and more renewable energy is connected to the system, and then more and more extreme weather happening, especially flood in Malaysia. So we need to take into consideration all of this problem when we analyze, or we want to ensure the system operate well. And then thirdly, we need to have a new formulation in terms of design, optimize the design of renewable energy so that it is suitable to the system and will not cause any harmful, such as transient stability, voltage stability, and so on. And finally, I will say that the challenge that happening now in terms of renewable energy penetration and also extreme weather, it's opened up a lot of research area, not only in power system. It can be in computer science, whereby you can use a deep learning, for example, to analyze the weather so that it can do a good prediction. It can use to analyze the irradiance of the sun so that we can estimate after 20 years what happened to our solar farm. Is it still okay or not? It can involve the civil engineering in terms of designing a substation that are prone or strong to handle the flood, for example. And geology, a lot of geography. There are a lot of areas that nowadays everyone need to work together, not only single discipline, but every discipline, sensing, communication, all of that will really help us to produce a solution that to address the problem in the current problem nowadays. All right. So with that conclusion, I end my presentation. Dr. Hemi Rizal.
Well, that was excellent. A very complete presentation about nature-inspired algorithm. And you went through some important topics related to distributed generations and then extreme weather. After that, Professor Hazli started to discuss a number of examples of application of optimization in power system. Of course, before you try to introduce the power system, the optimization first, and indicating that this nature-inspired algorithms are very slow and therefore very useful on the planning and design part of the work, not really application where real-time requirements are essential. And there are a lot of examples that have been explained, starting from in my note, There is a national network reconfiguration, energy management in microgrid. You mentioned about energy storage as well. Then I think, yeah, it was electric vehicle, how it is changing the operation of distribution network. You are also discussing about load shedding, network splitting, and the last part was about resiliency of the network. Of course, in regarding the extreme weather. The example was about low float water, which quite relevant in Indonesia and also in Malaysia. It was very interesting, and I hope there will be a lot of questions. So I'm opening the opportunity here. Yeah, if you want to see my face, Professor Hasli, I'm waving now. So the camera and the microphone is not at the same time.
Okay.
So we have also
Irnada.
Irnada there. Okay, I'm opening a question session, please. Pananda.
Thank you, Mr. Assalamualaikum, Mas Lee. Nice to meet you. Mas Lee.
Yeah.
Firstly, I want to say thanks for the time during presentation for us here and Faculty of Engineering University of Bengkulu.
Irnada not so clear lah. Your voice is not clear. Can you agak sayup-sayup
Sorry.
Okay.
What was it? So, okay. Mr. Aziz, from your presentation, I can conclude some points. You say that maybe as we know that one of supporting factor for successfully of our research is data availability.
Better.
Talking about data, I had a bad experience in my research.
Bad experience.
Yeah. Maybe I want to compare with your country. I almost 1.5 years or maybe almost 2 years I get problem to access data, especially big data that I need for my research based on machine learning research. Even though the data that I need not such a secret data like maybe like data, the data, only a general data, but it's really difficult to access the data. Maybe Mr. Noval is my co-promoter. He knows what happened to my research. For this case, I want to just compare with your country. What about Malaysia? Is that also difficult to access the data, especially for big data, for the research based on or maybe you can explain how your country manages the data, especially for big data. Just to compare with our country. Thank you, Mr. Hati, for your time.
Thank you.
Waalaikumsalam.
Irnada, would you like to respond immediately, sir?
Okay, all right. Okay, thank you for the question. Yeah, so I think that is a valid question, especially about the data. Some of data very confidential and very difficult to get, especially, for example, from the power utility. Yeah, that's why before we start whatever research, we need to think about the data. We need to anticipate. We discuss apa they want to do deep learning or artificial intelligence, whereby we need to have a lot of historical data in order to train our model. Yeah. So actually there are open source data in electricity. Also there are open source data whereby you can get it. For those who are doing like biomedical, there are open data for biomedical. For example, the X-ray of cancer, they are available. But for our area, like my area, electrical, usually the data, historical data like load data, the load demand data is nowadays is open source. It's available in Malaysia. We have the website whereby everyone can access the data. Outsider also will know how many load demand at every 5 minutes. It's a real-time data. There are also data like irradiance, the large-scale solar, because all the data is integrated. So we can see the amount of irradiance for every 5 minutes in Malaysia, the whole Malaysia, for all the large-scale solar, LSS. So some of data is available. So that's why before we start our research, whoever want to do research, you need to think first. Is it the data is available? Is it the data can be accessed or not? If there is no accessible to the data, what is the option? Because there are options like open data, as I say, certain area they have the data openly. Like in Australia, they have the data on the customer usage for all electricity for almost all the customer, but they didn't put the ID, so they have that pattern. So there's open source data. So I think the same issue, like if you want to get the data of network data from the power utility, they will not give it because for them it's confidential. But if you have friends, usually they will help you lah. But when you want to write a paper, you cannot mention about the actual data. Yeah. So again, before start your research, maybe for new student, you need to first to think about the data. Is it okay or not? If there is no accessible, what is the option that you have to use the open data? But if also not available, better to think other research area lah. That's the challenge. Okay, all right. Thank you.
Thank you. Yeah, actually, maybe 2 years back, I was actually thinking about flood data and trying to access the data. The city was Jakarta, but having both flood data and network data, it's very, very, it's not difficult. We still couldn't get the data. So that was one of the problems.
I understand.
Yeah. I want to ask about when the situation is not allowing us to have a lot of data, but we still want to work on particular problem. Is there any alternative, sir?
I think depending, as I said earlier, depending if we can use one of it is we need to use another option. If you don't have data, we need to create our own data, but the analysis you must consider a lot of probability, meaning, for example, if you assume this is a data of Malaysia irradiance, so you need to do analysis, probability analysis. I mean, you need to create for example, the probability density function to create your analysis will be on the data that having assumption on the error. How much is the error? Because we don't have the actual data, so we have the baseline, but we know that in general, the range of the data will be higher or lower. So we need to do a lot analysis in terms of probability. So that's another way to do that. If you don't have the actual data, historical data, so there's no other way that I can think of at the moment.
Okay. Yeah. Okay. We can work on the data.
Yeah.
itself.
So
what happened in my city, in Bengkulu city, in our city, where this university is allocated, we have a cycle of 8 years. Every 8 years, we will have a very large flood. So our houses will be flooded. So it's a city scale. We believe that it's kind of periodic, every 8 years or so. So thinking about your last presentation about the extreme weather when you do this network splitting, something like that, I might be able to get the network data, but I don't really have any way to get the flood data. Maybe it is better to cooperate with civil engineers. Maybe they might have a proper way to simulate the flooding processes and decide which tower or which transformer will be will having problems, and how the possibility to have network splitting is in your presentation. How about students or other participants? Is there any more question, please?
Before that, maybe Dr. Novalia, I just want to respond to your comment just now about because I did one, my PhD student did one research. There was 2 PhD students doing on, 3 actually doing on power system resilience. So the last one, he did on this network restoration. So in this work, number 1, he used historical data of Malaysia 20 years, because in Malaysia we have ministry that hold the data. I mean, they know the amount of rain, they relate the amount of rain and also the flood, the height of the flood. So based on this data, we create an equation to estimate the flood, the height of the flood. I mean, because usually in Malaysia, we have a lot of hang on.
Sorry.
Okay, all right. So sorry. Okay, so what we did is that we are using the historical data in Malaysia to relate between the collection of the rain, because there is a methodology whereby we can relate between the collection of the rain within 1 hour, how many millimeter, and the flood, the height of the flood. So from that, we create a equation just using curve fitting technique, we create equation so that if we know how much is the rainfall for 4 hours, for example, we will able to estimate the height of the flood. And then we have confirmed that when we visited one substation, trigger power substation, and we use that equation to see whether our assumption correct or not. And we found out that when we check at the substation and we look at the flood mark on the substation, we find out that the estimation is quite close to the actual happen, very close. So actually, if you have the data, actually that data is about, I do not know in Indonesia, but Malaysia, we have the historical data, and we use that to create the equation, curve technique, so that, let's say, if the area we know the rainfall, how much the collection of rainfall, so we're able to predict the height of the flood. Okay, and then from that, my student using this probability density function to create the distribution of the raining. And then from that, if you know we're using this what do you call it, the Google Map. We know the location, we know the longitude and attitude position of that too. We know the height of the ground. We can do good estimation actually. And actually some of the tools is available in the website. It's just, but the one that really expert is civil engineering, and we learn from them actually to use certain tools that are available.
Okay.
So, right.
That was very helpful. I might try to do that with my student here.
So if Pak Novalia interested, you can email me. I can share the papers related to what my student did, so get ideas what they are the tools that are being used.
Okay, I will email you, Professor Asli. Okay. Okay, I'm opening another opportunity to have comments or questions. Bapak, Ibu, adik-adik yang ingin bertanya, silakan.
Adik-adik
Adik-adik. While waiting, Prof. Asli, as far as power flow is concerned, what kind of software are you using? Are you using MedPower or something else?
For load flow analysis, because we are usually using this open source of the power flow lah. MedPower, yes, and sometimes we are using this the code from Hadis Saadat book. They provide the code on load flow. We're using that as well.
Okay. How about OpenDSS? Have you used it?
Yeah.
Okay.
We have experience using that for distribution.
Yeah, for distribution network.
So, Pak Novalia, your area memang on power system,
Yeah, I've been working in power system. I have experience with genetic algorithm, PSO. Yeah, I've been also using mathematical optimism as well. Actually, I have some paper still on preparation that might need your expertise as well.
Sure.
Yeah. I'm still waiting, but there seems to be no one is waving their hand until now.
Sudah lapar.
Sudah lapar ini.
Tengah hari.
Well, majority of us are bachelor students.
Okay.
They may have some difficulties to grasping your presentations, but I believe most of us are actually getting the major or the big picture of the
the big picture.
Yes. The tables may be confusing, plot may be confusing, but I think the big picture are understandable to most of us. So we should wait for 1 minute.
Yeah.
Otherwise, well, if there are no more questions, I think we can somehow end this. It is lunchtime already. We do hope that sometime in the future you might actually in person visit Bengkulu.
Yeah, inshallah. I'm happy to visit to come over there.
Okay. Sepertinya tak ada pertanyaan. So, Mr. Hamzah, would you like to maybe give some closing remarks?
Well, okay. Thank you, Dr. Noval. Thank you, Professor Hazli, for your talk today. I'm really sorry that I cannot fully attend your talk because I need to do something else due to management work.
Understand.
But anyway, I really thanks for your talk, and I really hope that in the future you will provide your time for another public lecture session.
Inshallah.
I think that's all from me, Dr. Noval.
Okay. Also, maybe Professor Hasli would like to have some closing remarks as well.
Okay. All right. So just to conclude my presentation today, as Pak Nova already mentioned, that maybe you cannot understand the details because some of it very detailed on the power system, but at least you understand that optimization technique have different technique, mathematical technique, heuristic technique, or meta-heuristic technique. And each of them actually have their own advantages. Okay, so sometimes we also can apply optimization using combination of mathematics and also meta-heuristic technique to maximize their advantages. Okay, so at least you understand what is optimization technique, why we need to optimize, what is the objective function, and what is the constraint. And if you understand that, you can apply optimization technique in any problem, not necessarily power system or electrical, mechanical, civil. A lot of work nowadays using optimization for different purposes. Yeah. So I think that's all. Thank you very much to the organizer for inviting me. I'm very happy to share, and I hope that in future I can visit your university. Thank you.
Thank you very much, Professor Hasli. And as a moderator, also would like to thank the audience for your presence, your participations. I'm sorry for any mistakes, but there is one important thing that we have to take a picture first. So please, everyone, close your, open your video. My video and sound are different account now. You can see my video here, but everyone else, please open your camera so we can have a picture. Gallery. Okay. Can anybody, someone help me to let me do it? Cheers. Okay. Okay. How many pages we have here? Okay. Okay, thank you very much, everyone. I'm happy that we finished this public lecture in a good manner. Again, thank you very much, Professor Asli. See you next time.
Inshallah.
Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih.
Salam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.
Thank you. Bye-bye, everyone.
Thank you, Pak Noval.
Thank you.
You can leave.